Finally, the cloud native monitoring application is ready. This DevOps project is all you need. You will learn how to build an application and deploy it on Kubernetes from scratch. Doing this project can help you get a job faster and it will make your resume shine. So complete this project and showcase your skill. Let me explain you what we will be doing in this project using an architecture diagram. Throughout this project, we will learn how to create a monitoring application in Python using Flask. We will start by building the application and then containerize it using Docker. We will create a Dockerfile. After that, we will build the image and run the container locally. Once we have our application containerized and running locally, we will then create an ECR or Elastic Container Registry using Python Boto3 module. In ECR, we will push the Docker image to store, retrieve, and use the Docker images in secure and efficient manner. Next, we will move to the deployment phase where we will create Elastic Kubernetes cluster with nodes and deploy the application on Kubernetes. We will create deployment and service using Python so that our application can be accessed from the internet, which is deployed on Kubernetes. So excited for this project? I know you are, but there are a few important things that I want to share with you. This project is going to teach you a lot of things: Kubernetes, Python, Docker, a lot of things, and this is going to be a difficult one, so you will face issues. When you face problems, try to troubleshoot it by finding solutions online, read a blog, watch a video, read documentation, anything before you ask anyone for help or before you drop a comment for help. So try to search online. When you search things online, it will make your concepts clear and you will be able to understand things more in depth. So try to find your solutions yourself. But if you still don't get any answers, feel free to drop your comment and I'll help you out. And if you have a membership for CloudChamp, I'll explain you things more thoroughly in depth. So get your membership today. Make sure you complete this project and share this on your LinkedIn. I'm going to see how many of you can complete this project and deploy your application on Kubernetes. Tag me to check how many of you can do this challenge, and let's see. So let's start with the video. Alright, so I'm here on my computer screen and we can start with the project. But before we do that, there are a few things that you need to have in order to get started. The first one is to have an AWS account. So we are going to do things on the AWS cloud. So we need to have an AWS account because we will be creating Kubernetes service, ECR, and deploying it on AWS. So we need to have AWS account. After we have the account, we need to give programmatic access so that we can do things on the CLI or using Python. So we need to give programmatic access and configure it with a CLI. To do this, you will need to create access key and secret access key in your AWS. If you don't know how to do it, just go to IAM or click on security credentials option here and you will find the option where you can create access keys and secret access keys. These keys are required for us to have programmatic access. So in AWS, whenever you want programmatic access, you need to put the access keys and you can create it from here. I've already two created, so I cannot create it, but you can create it by clicking here and then put those keys on your terminal or in your VS Code by running AWS configure command, and this will ask you for access key. Put your access key here, your secret access key here, your region name, output, and boom, you are now connected. To cross check, you can just run AWS IAM list -users. This is one of the command to check which users are present in your account. If you get the user that are already in your account, which means you are successfully connected, so I can see all my accounts. This is to cross check so that you are not using any of your company's AWS account or you might get fired. So I want you to check that you are using the correct account. For me, if I show you here, I have an account named as Nasi, and you can see this is the same one, so I'm correctly connected to my account. This is the step you need to be doing because we are going to use Python to manage some AWS service and we need to have programmatic access. So after you have programmatic access, you also need to check if you have Python 3 installed in your machine or not. And to check this, you just need to run Python 3 -- version. This command will tell you if you have Python installed or not. So I have Python here with 3.8.10, which means Python is installed for me. If you don't have it, go to the official documentation of Python and install it from there. Along with Python, you also need Docker and kubectl. We are going to use Docker commands to create a Docker file, for which, because we are going to Dockerize our application, the one we are going to create, we're going to create Docker file and run Docker commands like Docker build, Docker run. So we need to have Docker installed, and to check that, simply type Docker or Docker -- version command and it will give you that Docker is installed. For me it is 20. You can choose to install any version, but you need to have Docker installed. Along with Docker, we also need kubectl. So kubectl is a command line tool for Kubernetes, and we're going to run those commands to see if our pods are up or not, if our nodes are ready or not, if our service is ready or not. So we need to have kubectl as well. And to check kubectl, you just need to run kubectl and version command. This will give you the version. I can see here I have kubectl installed and I get this output, which means kubectl is installed for me. So you need to have Docker and kubectl as well. Lastly, you need to have a code editor, because that's where you're going to write the code. So I have a code editor which is VS Code here, and I'm going to use that. So now after you have everything installed, you are ready to get started. So I'm going to now get started. Let's create a folder for our application. So in my home directory, I'm going to go ahead and create a new folder, say native app, cloud native monitoring app. Okay, so this is my folder, and I'm going to create all my files here. So I'm going to open this in my VS Code. So let's open a VS Code here, and I'm going to click on file, open folder, and I'm going to choose my cloud native monitoring application folder that I created right now. Perfect. So click on open here. Now I'm inside my folder, which is completely empty, as you can see, and inside this I'm going to write the code for my application. So this application is a Python application, so I'm going to create a new file, name it app.py. So every Python application should end with .py as an extension, and I'm going to do that. So this application is a monitoring application which is going to get the CPU and memory metric. So in Python you have different modules to do some task. If you want to get CPU and memory metric, you need to have a module name as psutil. So I'm going to import that on the first line. So I'm going to say import psutil. And if I show you this, it says psutil is a cross-platform library for retrieving information on running processes, system utilization like CPU, memory. So this module is going to be used to get the CPU and memory of my server on which this application is going to run. So we have it imported. Next thing, this application is going to be run in Flask. So we're going to use Flask framework to create this application. So we need to have Flask module as well. So I'm going to say from Flask import Flask. Okay, so we have two modules here. One is psutil to get the CPU and the memory, and Flask to create the application itself. Now that we have this two ready, I'm going to create an app here. So I'm going to say app equals to Flask, and inside this I'm going to say underscore name. And you will understand this once we do the few other lines in the code. So I have an app created which is a Flask application, and I've given this parameter as name here. So now that the app is created, let's set the path of where the application is going to run. So I'm going to say @app.root is going to be the slash, which means it's going to run on home path. So this slash says home path. So whenever a user comes in at the home path, the application is going to run. And what are we going to show it? So let's create a function here. I'm going to say a function which is going to be index. The name of the function is index, and we're going to run this when the user comes at this path. So inside this function, I'm going to define three variables. One is CPU. So I'm going to say CPU underscore percent equals to psutil.cpu. So I want this CPU percent to hold the value of my CPU usage. So I'm going to say that, and then next I want to also store the memory utilization. So I'm going to say mem underscore percent equals to psutil dot virtual memory here. So virtual memory, and this virtual memory I want it in the form of percent. So I'm going to say dot percent here. Okay. So we have two variables now. One is CPU, one is memory. CPU to get the CPU usage, and then memory to get the memory usage. So next I'm going to say message equals to none for now, but let's include a functionality in here saying that if the memory is more than 80% or if CPU is more than 80%, we should get a message that CPU is high or memory is high, and then scale up. So let's say that. So if CPU underscore percent is greater than 80, so if the CPU percentage is more than 80% or memory percent is more than 80, then do a message, say a message that message equals to high CPU memory utilization, something like that. Utilization detected, please scale up. Okay, so we have a function here which is going to store CPU, memory, and a message, and if the memory or CPU is more than 80%, we want this to be shown. This function is not returning anything, so we're not going to get any output. So let's get a return statement. So I'm going to say return a statement saying that CPU utilization equals to the value stored inside this. So I'm going to say CPU percentage and memory utilization is going to be the value stored inside this mem percent. So the value here inside mem percent. Perfect. Now we have a function ready to get the CPU and the memory, and to show if it is more than 80%, we will get this message. And once the function is called, we are going to get this statement here. So whenever user goes into this path, he will get the CPU and the memory as defined inside this function. So we have a function ready. Let's say if name of the app, which is here, if this equals to main, then run the app. So say app dot run in debug mode. So debug equals to true, debug equals to true, and the host of the application is going to be 0.0, so that it can run in my local machine. So I can say host.0.0.0.0. Okay, so this is our application here, which is going to use psutil flask to get the CPU and the memory, and then show this message whenever we come at the slash path. So this is our application. I can go ahead and try to run it. Opening my terminal, I can just say Python 3 and the app.py, and it will run for me. For you, if you try running this, you will get an error saying module not found for psutil or module not found for Flask. So what you need to do is to just run pip3 install and the name of the module, which is psutil here. So I'm going to say pip3 install psutil or pip3 install Flask, and then it will install it. So for me, I have already installed. It says requirement already satisfied. If you don't have it installed, you need to run the command pip3 install psutil. And what I can do is I can create a requirements.txt file here to add all the necessary dependencies or the modules that you will be using throughout this course. So I'm going to add all the modules that you will be using. So here is all the modules we're using: Flask, markup, safe, and then all these different along with psutil, plotly, and Kubernetes and Boto3. Because in the earlier part, in the later sections of the video, we will be creating ECR using Boto3, and we're going to manage Kubernetes deployment using Kubernetes Python client. So what you need to do now is just run pip. After you clone this repository, or after you have this file in your local machine, just do pip3 install -r requirements.txt, and it will start installing everything for you. For me, everything is there, so it's not installing anything, but for you, it will start installing it. Okay, so now we have our application ready, and after you install all the modules, you just need to run Python 3 app.py, and this application, it says, okay, there is an issue saying import name is wrong. Equals to main. So it says app equals to Flask. Okay, sorry, my bad. I just removed it from here. I have to copy and I cut it out. So I'm going to say here __ name. Okay, let's save this now. I'm going to exit from here, Python shell, and run the command again. So I'm going to say Python 3 app.py, and now you can see it's running on port 5000. So I can open my browser here and run localhost port 5000. So you can see I have an application which is showing me the CPU utilization and memory utilization, which is 21 CPU, memory is 55. If I refresh, I'm going to get the real-time metric, which means my application is running properly, and you can also see the logs here. So every time I refresh, I will get a log here, which means I have a monitoring application created in Python using psutil and Flask. So this is how you can create it, even though this does not look so fancy, but we still have the information that we want. So we have the CPU here and the memory here, which means we have our application running, and everything is performing properly. So this is how you can create an application in 16 lines where you can get the CPU and the memory. Now let's try to change this style and add something so that we can make it look good. So I'm going to stop this app for now, clear everything, and to add a style in your Flask application, you need to use something known as render template. So render_template, and I'm going to use a file named as index.html. So I need to first create a folder, name it as templates. Inside this template folder, I'm going to create a file, name it index.html. Okay, so I messed it here. I'm going to rename it, make it just index.html. Perfect. Now in this index.html, I'm going to give you the code that you need to enter, and I'm going to explain you that as well. So this is a index.html page where you're going to set the style in the form of gauge or the indicator to show us the memory and the CPU. So here there are a few parameters that we need to enter. One of them is CPU %. The second is message here, and then the memory %. So this is a different file, and we need to make the change here in the app.py so that it can use this index.html. So I'm going to change this return statement here, remove this part, and say render template, use a file which is index.html. So I'm going to say index.html, use this file. Inside this file we have certain parameters that we need to add. So we have CPU %. In this, if you can see here, it's asking for mem % and CPU %. So what is the value of this? I'm going to set the value as CPU _% equals to the value that is stored in this variable. So equals to the same CPU percent equals to CPU percent. If you had something else here, you need to put, let's say if you had CPU metric here, so you would be setting CPU metric equals to CPU percent. If you have mem metric here, then you will be saying mem metric equals to mem percent. So I'm going to say mem percent equals to mem percent again, which is going to store the value of memory, and then message equals to, so I mean this here we have a small m, you can see small m, so I'm going to say message equals to the value that is going to be stored here. So if the CPU is more than 80%, it should show us this value. So I'm going to say message equals to message here. Okay, all right, now we have added some style to our application. So we have added render template to use this index.html, which is going to show us in some kind of format. So I'm going to save this. Here's my file. I'm going to save it as well. And then now run the app again using Python 3 app.py, and it is now running on port again. So let's open the refresh now. If I refresh now, you can see that this CPU and memory is shown in a good format. So we have CPU here in this percentage symbol, and we have memory here. If I refresh, I will get the updated real-time value. So this is how you can create your own Python monitoring application, and it is using the style stored in index.html, which means everything is working fine. So now that you have this application ready, and it is now running in the index, it is now running in localhost or 127, which is in my local machine. How can I run this in Docker container, or how can I run this in Kubernetes cluster? So to do that, we will need to Dockerize this application now. So let's try to create a Dockerfile so that we can deploy this application in the form of container. So I'm going to stop this application now, and let's try to create a Dockerfile for this. So we have now seen how to create a monitoring application which is going to run on localhost. Let's try to deploy this as a container, and to do that we are going to have to create a Dockerfile. So I'm going to say Dockerfile here. Inside this Dockerfile, we need to define the instructions so that our application here can run in the form of, can create an image and then run in the form of container. So this is the Python application, and we are going to use Python as our base image. So if I go here in my browser and go to Docker Hub, so Docker Hub is here. I'm going to Docker Hub and then search for the Python image. So you will find all the different images in your Docker Hub if you don't know what Docker Hub is. So I'm going to search for Python, and you can see that this is the official Python image. And inside this image you have different versions. So we're going to use the version which is 3.9 Slim Buster, this one. So I'm going to say in my Dockerfile, I'm going to say from, we need to define the base image. So the base image is Python colon 3.9 hyphen slim hyphen buster. So we are going to use this one here. So we are saying that use this as a base image. So you can see still set the base image to use for subsequent instruction, and after we set the base image, we're going to say set the working directory. So when a container is running, which directory should it work in? So I'm going to say work directory is going to be /app. So we have set the working directory as /app here. So set the working directory for any subsequent commands that you're going to run. So all the commands that are going to be below here are going to be running in the /app path. So now I have the base image ready, I have the working directory set. I am going to say that this requirement.txt should be inside my app, so that my container should be having all the dependencies. And this is why Docker is very much used, because Docker has a container which has the application code and the dependencies, which can run in any platform no matter if you have the module installed in your machine or not. So that is what we are going to do. We're now going to copy this requirement.txt from a local machine inside this image. So I'm going to say copy requirements.txt in the app, so saying dot. So we are right now in the app. If I copy it from here, I'm going to copy it inside the app. Okay, so now I've copied this. Let's go and run this command, which is going to be to install all this. So we run the command pip3 install -r requirement.txt. Similarly, I'm going to say run. So run is the parameter to run the commands, execute any commands on the top of the current image. So I'm going to say run pip3 install -. I'm going to add a new parameter saying no cache, so that there is no caching issues. No cache -dir, and then -r requirements.txt. Okay, this instruction here is going to install everything that is here which is required for application to run. So after the installation of the requirement.txt, we want the code which is app.py, the template, everything inside this folder. So I'm going to say copy again. So copy everything that is there inside this directory to the app directory. So copy dot and dot. Perfect. Now we have all the application code inside our working directory, which is /app here, and we are now ready to run the application. But before we do that, we need to set the host as 0.0. So I'm going to define an environment variable saying env equals to let's say is flask underscore run underscore host equals to 0.0.0.0, which means even though I'm running this in Docker container, it should work fine because I'm setting the host as 0.0. which is not restricting my application. So after I do this, I'm going to expose some port. So this application that we were running was running on port 5000. So we need to expose a port saying, so expose, if you see here, it says the instruction is to define a network port that this container will listen on at the runtime. So the container is going to run on 5000. So I'm going to say 5000 here. Okay. And lastly, we want the command to be running so that this Flask application to run. So here we have app.run. Similarly, we will say cmd, and then inside this square bracket, I'm going to say Flask, and then so we have executable and a parameter. So executable is Flask here, and the parameter is run. So I'm going to say run. Okay. So we have our Docker file ready. You can see first we define the base image, then we define the working directory where the application is going to run. Copy the requirement.txt from here inside the /app. Run the command to install everything inside the requirement.txt. Copy the code from here inside the image. Set the environment variable, expose the port, and then lastly we are going to run the commands to start the Flask app. Okay, so we have our Docker file ready. As you can see, we have defined everything here. So let me show you the workflow. If you see here, whenever you want to create a container out of your application, you need to first create a Docker file, and using that Docker file you can run the command docker build to create an image which will then be used to run a container. So now we have a Docker file, we need to create an image out of it. So we're going to go here in the VS Code and say docker build -t to give the name of the image. I'm going to say my Flask app, and then we need to say dot to tell Docker that use the Docker file that is present inside this directory. So I'm going to say docker build -t my Flask app, and then dot. Once I press dot, everything that is defined here will run one by one. So I'm going to say yes, and then it is going to pull the image, which is Python 3.9 Slim Bluster from Docker Hub. So I'm going to pull it. So you can see it's downloading the image from the Docker Hub to use the base for this image or for the container that we're going to run. After it pulls it up, it is going to then define the working directory as app, copy this requirement.txt thing, and then start installing it. So it has defined it. Now it is installing all the requirement.txt things which are markup, safe, Flask. This is very important so that our application is full of dependencies and code, and it should not show us any error. Now it is installing Boto3, as you can see here, and lastly it will install Kubernetes, which is here, and then it is going to go to the next step, which is to copy the application code inside the app directory, set up the environment variable, expose the port to 5000, and then lastly run the command. So you can see here it's going to install all the dependencies. It has installed all of these dependencies here, which are going to be required for this application to run properly. Once it is done, it will move to the next step, which is here. So it is showing us a warning, which is not a problem because it's not an error, so no problem. So now you can see it has copied all the code, and now we have an application here, which is my. So I'm going to run Docker images to check how many images do I have. So you can see there are 2 images. One of them is just created 9 seconds ago, which is here. So we have an image created from our Docker file. So we have a Docker file, we created an image. Now we have an image. Let's create a Docker container. So for that, we need to run the command, which is docker run command. So I'm going to say docker run -p to define the port. So the port is 5000 here in the container. I'm going to say bind it with my port 5000 as a local machine. So which means when I run this container, it should work on 5000 in my local host as well. So and then lastly, I need to put the image ID or the image name. So I'm going to copy this ID and paste it here. So it's going to be docker run -p, the port number, and then the image ID. Once I do this and press enter, the container is going to run now. So you can see a container is running on this port, and I can open my browser, do localhost 5000, and you can see here this application is now running on Docker container. So we get the CPU and the memory of the Docker container that is running here, and you can see we are also getting the logs, which means our Docker container is running our application very properly. So we have our container application containerized and run in the form of Docker container. I hope you have your application now in the form of container following this video. If you have it, just take a screenshot, upload it on your LinkedIn, on your resume, put it on your resume, showing that you have knowledge of creating an application in Python, then containerizing it using Dockerfile, Docker image, and then Docker container. So now that we have a Docker image created and a Docker container, let's put this image, which is here, to the repository. We can push this either on Docker Hub or on ECR, but we are going to push this on ECR because we are going to deploy application in the form of Kubernetes cluster. So I'm going to open my AWS, and you can find it here. Let's go to ECR repository. So this is the place where you're going to push your Docker image, which is going to be required to host your application in the Kubernetes cluster. So let me show you how it looks and what we need to do now. So, but till now I hope you don't have any confusion and you have your application running in the form of container, which was running locally earlier. So now let's deploy this in Kubernetes. And you don't need to have any prior knowledge of Kubernetes to do this task. I'm going to show you and explain you everything from step by step, so don't worry about it. So here we have ECR, which is to share, deploy container software publicly or privately, and we can go ahead, create a repository which is going to store our image, which will then be used by containers in Kubernetes. So I can easily go here and click on create, fill in all the details and create repository, but that is no fun. So I'm going to show you how you can create ECR repository in this in my VS Code using Python. So using this, you will learn how to use Boto3 module to create stuff in AWS. And let me show you what Boto3 is. So if I go here and show you the documentation, here is the documentation for Boto3, which is an AWS SDK for Python to create, configure and manage AWS services. So you will find all the documentation here. Let's go to ECR. So if I search for ECR here, you can see ECR should be present here. So I have the ECR here, and when I'm going to use Boto3, I need to first define the client as ECR, and then I can use any of these API calls. So we are going to create a repository. So I'm going to choose this API call, which is create repository, and you can find all the information and the parameters here. So using this parameter and the information, let's try to create a repository in our Python image. So in here, I'm going to create a new file, name it ecr.py. And for us to create anything in AWS, we need to use Boto3 module. So I'm going to say import Boto3. So Boto3 is the SDK used to create AWS resources in the cloud. So I'm going to say that. And then next, if you go to the documentation, first thing you need to do is to set the client as ECR repo. So you can see this is what we need to do. So I'm going to say ECR_client equals to Boto3.client. And the client is going to be ECR because that is where we are going to run. So if you remember my previous video, I've shown you how to create EC2 instance, and we have also set a client something like this for EC2. So now we're going to run ECR. So let's go and define it. So I'm going to now create a repository. So I'm going to say, first define the repository name. So I'm going to say repository underscore name is going to be, let's give it my cloud native repo, something like this. After I define the repository, I'm going to call the create repository function here. So I'm going to say response equals to ECR_client dot create underscore repository. So create underscore repository. So we're going to use this API here, which is this one, create repository, and it wants us to put some data like repository name. So repository name here is the name of the repository. So I'm going to say create repository, and inside this I'm going to define the name of the repository as, so I'm going to say, let's copy this here, repository name equals to this value stored here. So I'm going to copy this, paste it here. Okay, now this is going to create a repository for me, but I want to have few things in my console after things are created. So I want to get the repository URI, which is somewhere here. Where is the repository URI? Okay, so you can find it here. This is the repository URI for your repository, which is going to be used in the next sessions when we are going to deploy this application in Kubernetes. So I'm going to print it here in my terminal. So I'm going to say repository underscore URI equals to, from the response, I want you to give me repository URI. So I'm going to say repository here, and I want to get the URI. So I'm going to say copy this and paste it here. Alright, so this will store the value of repository URI. Let's print it out. So I'm going to say print in the bracket, I want to have repository URI. Okay, alright. So this is the code to create ECR repository, which is going to hold our image. So I'm going to now run this code. So let me clear this here and say, after I save it, I'm going to say Python 3 and then the name of this file, which is ecr.py. So ecr.py. Once I run this, it should give me a repository URI. So you can see there's a repository URI saying this is my account ID, DKR something, my cloud native repo. And to show you this in my console, we should have a repository created here if everything is okay. So you should see a repository here which we have created, and there's no images right now in this, but we have successfully created a ECR repo using Python. So this way you have learned how to use Boto3 module in Python to create stuff in AWS. So we have successfully created a repository. Let's try to push our image in here. So if you see here, we have push commands present, and let me explain you this one by one. So we need to run the command one by one to push our image that was there inside our local machine in this repo. So first copy this and go to your VS Code, paste this. This command is going to get the password and store it here, and the output should be login succeeded if everything is okay. So I'm going to run this command and it should show me login succeeded. sure I can run the next command. So it says login succeeded, which means everything is okay. Now let's run the command docker build -t to create an image out of this Dockerfile. So I'm going to say docker build, and the name of the image is going to be this my cloud native repo. I'm going to press enter, and it has successfully created an image. Now after I create the image, I'm going to tag it to use the name as this. So this is the name, and we want this to have a name because ECR will store the image under this name. So I'm going to run this saying docker tag change the name of my cloud native repo to this name. So once I do this, it will change it, and then I can push the command. So I can run docker push the name of the image, which is this one, after we changed it here. So I'm going to run docker push, and it will start pushing the image from my local machine to my Docker hub, to my ECR. So you can see right now there is no image, but it has started pushing to my ECR repo. You can see all the steps here. So it says the push refers to repository this one, and it is starting to push. So once this is pushed, we can see it here in the images section, which will then be used to deploy our application in the form of Kubernetes. So now, as it is going to be pushed, let's go and go to Kubernetes, because it will take time for us to create a cluster and nodes. So I'm going to go here, click on add cluster, click on create cluster option here, give this cluster a name. So I'm going to say it Python, or let's name it cloud native cluster. Okay, so I'm going to use the default version. This is the role. I'm going to define no tags here. Click on next option. Default here, I'm going to select some of them. So I'm going to not select 1E, only 1A, B. So you can choose any subnet you want. I don't have capacity in 1E, so I'm not choosing that. I'm just using 1A, 1B, 1C, and 1D, which is okay. Alright, now I have 4 subnets here. Sorry, 5 subnets. So 1F, I'm going to remove that as well. So 4 subnets. It is okay, you can launch it any number of subnets, that's not a problem. I'm just selecting here. So, and then I'm going to select my security group. Make sure the security group has proper ports, which is 5000 here, to run your application. And I'm going to click on next here. Click on next. I don't want any logging, no add-ons. And then after I do this, I'm going to scroll down to click on next option, and then review and create. This will create my cluster, and I will have a cluster in my account, and sometimes it is now in creating state. So let's wait for this to come up, and then if you see here, it says the push has been done. So if I go to my ECR, I should see a image. I'm going to go to my ECR, open this in a new tab, and if I show you here, you have inside this, I have an image here, which is the latest image. So you can see we have successfully created an image. We have also deployed this in a form of container, and we have pushed the image in the ECR. So I hope you have learned a lot till here in this point of the video. You have learned how to create an application, how to dockerize it, how to deploy a Docker container, how to create an image, how to write a Dockerfile, everything, and lastly how to push an image to an ECR repo. Once it is pushed, we are going to use the Elastic Kubernetes service, which is EKS, to deploy our containers in the form of Kubernetes cluster, so Kubernetes pod. So for that we need to have kubectl. So right now if I do kubectl anything, let's say get pods -n default, it's going to show me that unable to connect to the server because we haven't created the cluster yet. Once the cluster is created, we need to authenticate, or we need to connect it by running the command aws EKS config command. So let's wait for this to come up in running state. After it is in running state, I'm going to go ahead and create a node group. So we are not able to create it unless it comes up in running state. So I'm going to pause the video and come back again when this is in running state. Okay, so after waiting some time, we have cluster in active state. Let's go and create a node group. So I'm going to go to here, go to the cluster and go to node groups here. Give it a name as nodes, or anything, you can name it anything. Attach an IAM role, and I'm going to go ahead and click on next option here. In the next, I'm going to select Amazon Linux 2 AMI T2 micro. We don't need to have T3 medium because that's unnecessary. So I'm going to stay in free tier, and I don't want you to waste money, so use T2 micro. Next, remove T3 medium from here and select the desired size as 2. 2 is enough. And now I'm going to click on next option here. Select next to select the subnet. And here I'm going to click on create option, which will create the node groups having 2 nodes inside it, which is okay. Now if you go here in the nodes, you can find after some time that there are 2 nodes, so it's still in creating state, which is okay. Let's go to our VS Code and create Kubernetes deployment and services. So if I explain you what do you mean by deployment, let's go to Kubernetes official documentation to understand what do you mean by deployment and what do you mean by Kubernetes service. So we will require these 2 things to deploy our application on the Kubernetes cluster. So first, let's see what is deployment. So deployment refers to declarative update of pods and replica state. In the deployment, you will define what image do you want to use, what should be the name of the application, how many replicas should be there, all of that stuff. So inside this deployment, you will be defining that you're going to be using the image that we push to our ECR repository. We want to have 1 replica or 2 replica of the application. This is the name of the application. It should run on port 80 or port 5000. Everything that is going to be defined in the form of deployment. And Kubernetes will be using that deployment to maintain the state, so that there should always be replica, 3 replicas running all the time, it should use this particular image. So that is what I'm going to show you, how to create a deployment using Python. So we're going to integrate Kubernetes with Python. If you were to do it manually, you have to create a file something like this and then run the command kubectl apply -f and then the name of this file. Similarly, let's see what is a service. I'm going to search service here, and you can find service in Kubernetes. So service in Kubernetes is a method of exposing a network application that is running on one or more pods. So our application is going to be run on the pod, but for everyone else to access it outside the cluster, we need to have a service. So we're going to create a service so that our pod can be accessed to the outside world, either using load balancer or using IP address. So we need to create a service, and then we will be able to run this application on the browser or on IP address or on local load balancer's DNS. I'm going to go to the VS Code here, and to do that I'm going to first create a file name as kubernetes.py, where we are going to define all our deployments and services. So I'm going to say kubernetes.py, and to use Kubernetes with Python, we need to use something known as Kubernetes client. So this is the Kubernetes client used to manage deployment services using Python. So I'm going to say from Kubernetes import client and config. So client config. We're going to use client to update, to create deployments and services, and config to use the cluster. So the first thing is to load the Kubernetes config. So I'm going to say load the Kubernetes config and use the one that we created right now, which is here, and this one, sorry, this Python Cloud Native. So you're going to get the config which is stored here. So you can find all the config in the .config file. So if I go to cd.kube, inside this you can find a folder in our config which is going to have the data about our cluster. So this is what we're going to do. We're going to fetch the config, and if we do it here in the terminal, we do it using this command. So aws eks update kube config and then the name. So now we have loaded the config. I'm going to set the client as this. So I'm going to say create a Kubernetes API client, and now we're going to define the deployment. So we have already seen what is deployment. A deployment is a file which is going to contain the image name, number of replicas, the port which is on which the application is going to run. So let's define a deployment here in Python. To do it here, I'm going to show you. So this is the code which is going to define the deployment, and the name of the app is going to be my Flask app, and then we are going to use the container image, which is this. So I'm going to remove this and use the one that we have in our ECR repository. So I'm going to go to my ECR and copy this URI. So copy this and paste it in your code. So paste it here and now save it. This is going to define the deployment but not actually create it. To create, you need to run a command in the terminal which is kubectl apply -f deployment.yaml and then the namespace. But in Python you will be doing it using code. So I'm going to show you how can you do it. So here is the code to create a deployment. So you will say create this deployment inside the default namespace. Right now if I show you, I don't have anything in my default namespace. So if I do kubectl get deployment -n default, you can see that there is no resources found in my default namespace. But after I run this file, I will have a default deployment in my default namespace. Along with deployment, I also need services. So I'm going to define a service here. The service is used to expose your application to the outside world, and it will not work unless you define a service. So I'm going to define a service for my Flask app. The name of the service is going to be my Flask service, and the port is going to be 5000 on which the application is going to run. Now to create this, similarly, you need to run the command kubectl create and the name of the file having this. But as we are doing this in Python, we are going to use this code. All of this code is going to be there in the GitHub, so don't worry about it. I'm going to push this on GitHub and you can have access to it. So now we have in this file, we have said create a deployment and a service. So let's go and run this. So I'm going to say Python 3 and kubernetes.py. Once I do this, I'm getting an error saying cannot import client from partially initialized Kubernetes, most likely to do circular import. Finding few things, I got a solution saying that we need to change the name of the file to something else. Rather than using Kubernetes, I'm going to make it eks.py. Let's save it and try to run it again. So I'm going to say Python 3 eks.py. Once I do this, it's going to create deployment for me. And now if I show you here, it says let's try to run and see kubectl get pods -n default and -w to say in watch mode. And you can see after some time there will be a deployment. You can see a Flask app is here. It is showing us image status pull back off for now, but let's see if there's is there a deployment created or not. So kubectl get deployment -n default, and you can see a deployment is there, which is going to be not in ready state yet, but will come up in some time. And let's see the service as well. So I'm going to see the service. So if I do kubectl get svc, So we have a service here as well, my Flask service, which we created using Python. So you can see you can also manage Kubernetes application or any other DevOps tools using Python, which is very easy. Now that we have it here, let's try to see if our application is up or not. If you face any issues like image pullback or something, you can just go copy this and run the command kubectl describe pods and the name of the pod -n default, the namespace. So I'm going to say -n default, and this will give me all the detail about my pod. If there's any issue or any error, it will also tell me that. So it says back of pulling this, maybe the image is not correct, so I'm going to check the image once again and use a new one. So I'm going to copy this, remove this and use the one in my here. So I'm going to copy this. So let's see first if it is showing me the pods or not. So it says image pullback. What I can do is change the deployment right from here. So clear kubectl first get deployment -n default, and I'm going to get this deployment. I'm going to say kubectl edit deployment, and then the name of this deployment, which is my Flask app. You might not need to do this because you might have already created and put the right image here. Somehow I have changed this image, so I'm going to edit it here. I'm going to say -n default, and then it will open this in the edit mode. I'm going to go below. So this is I'm going to go to here in this section and delete everything, put my correct image URI. So sorry, the URI from here and paste it here. Okay, once I save it, I'm going to say escape :wq and then done. Once I do this, let's try to see if our pod is up or not. So I'm going to now check this, and within some time you can see container is creating now. After some time, this container will be in running state and we can then access it using, so you can see it is now in running state, which means the problem was with the image. Okay, now that it is in running state, let's try to expose our service. So I'm going to say kubectl get svc -n default, and we have the service here. So the service is this. I'm going to port forward this so that I can use this pod in my local machine as well. You can also choose this to change it to load balancer, but that is not needed for now. So I'm going to say kubectl port -forward svc / the service name, which is this one, copy paste, and then I'm going to say -p 5000 :5000. So I want this application which is running on 5000 to be running on my local host on 5000. So for now, if I show you before I run this, if I show you there's nothing running on my local host, but once I port forward this and press enter, okay, I think, let me confirm the command. Okay, it does not have to be -p, just this, and press enter. Once I do this, it will start port forwarding my application on my local host, and you can see it is saying that if I refresh, I will have the application here. So this is our application hosted on Kubernetes cluster, and we have learned a lot in this. So if you have this application in your Kubernetes, if you see this application on your local host, make sure you take a screenshot, post this on your LinkedIn, or you can also include this project in your resume, because this is an excellent project where you have learned everything from scratch on how to create a Docker application, how to create a monitoring application, how to containerize it, how to write Dockerfile, everything you have defined. So I hope this was very informative. I'm going to push this code, and you can find this code on GitHub. So if you go to GitHub, I'm going to paste the link in the description as well. So you can find everything in this repository, which is cloud native monitoring app. I have pushed the Dockerfile, app.py, eks.py, everything inside this repo. I'm going to update this readme so that you can have all the steps. But if you have any questions, any doubt, you can let me know in the comment section. Now once you have deployed this application on Kubernetes and you have took screenshot of this, post it on LinkedIn, tagged me, and defined in your resume, all you need to do is to clear your things. So you can go ahead and delete your Kubernetes cluster. So first thing you need to do is to delete your node group. So I'm going to go to node groups here, compute, select this node group, delete it so that you don't get charged. Put the name of the node group, it's just nodes here, delete. Now after some time, once it is deleted, then you can go ahead and delete your cluster as well. But now if you try to delete it, it will show you that there's nodes present which you need to delete. So I'm going to delete this. So it says it is going to be deleted. Lastly, you also need to delete your ECR repository. So select the repository, click on delete, and then type delete here. So this is how you will complete your project. Make sure you delete all the resources that you have done. And I hope this was informative. If you have any questions, any doubt, Let me know in the comment section and showcase your skills. You showcase your knowledge of Docker, Kubernetes, Python everywhere on your LinkedIn, on your resume. Thank you and have a good day.